Welcome to CS Explained. In this tutorial, I'm going to show you how to calculate a minimum spanning tree using the Kruskal's algorithm. So let's just jump right into it. The first thing you're going to see on the left, we have a graph that you are most of the time going to get. So what's the point of Kruskal's algorithm? Kruskal's algorithm wants to find minimum spanning tree. What is minimum spanning tree? A tree that gets to all nodes with the smallest possible cost. It is based on a greedy algorithm. So let's just jump right into it. If you've seen a CS Explained video on Prim's algorithm, then Kruskal's algorithm is going to be very easy for you. So first we've got a graph. What kind of graph do you have? You have a connected graph, means all the nodes are connected. You've got a weighted graph from 1 to 6, has a cost of 3. Connection from 6 to 4 has a cost of 15. So you have a weighted graph as well. And you also have an undirected graph. What does that mean? That means that cost from 1 to 6 is exactly the same as cost from 6 to 1. These three things are very important for you to understand. You, at this point, have a graph that is connected, weighted, and undirected. So, okay, and you're going to see this two rules. These two rules are main rules that you have to watch out for if you want to complete Kruskal's algorithm. So let's just jump right into that. The first one says, avoid the completion of the cycle. So what is a cycle? Typically, when you want to find the smallest possible cost for one path to the other, you do not want to walk in circles, right? Exactly the same thing apply here. You do not want to get from node 1 back to node 1. Why? Because you would be getting a whole lot of these costs and you would not get a minimum spanning tree this way. So for example, let's just color it. This would be one cycle. Or this can be one cycle. From 1 through all these nodes back to 1. Or this can be one cycle. From all these nodes back again to 1. You can have multiple cycles. Second one, you have to find the smallest possible connection on each step. Why do we need this second rule? Because at each point, if you're going to take the smallest possible cost, then you are definitely going to be able to find the overall minimum spanning tree. Now let's just get to the left a bit. You've got a hint here. So a hint says a minimum spanning tree must have v minus 1 edges, where v represents vertices, while each connection represents an edge. What does that mean? If I ask you on this graph, how many vertices do we have? All you have to do, add up all the nodes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 nodes or 9 vertices. Now if I ask you how many connections do we have, each connection represents an edge. So let's say, for example, from node 9 to node 5, we have a connection with a cost of 4. How many connections do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 13 edges or 13 connections. So that's very simple. Now in this case, according to rule on the left, we must expect 8 edges in our final graph. So that way you know you got your minimum spanning tree. You will not be able to get less than 8. And if you get more than 8, then this is a spanning tree, but it's not a minimum spanning tree. With these two rules, you have to be really careful. And if you really want to make this a bit easier for yourself, just create this table on the right. I suggest you copy it on the paper. So you're going to have table of weights, table of start nodes, and table of end nodes. Now be real careful here. Start node and end node doesn't matter. Why? Because this is an undirected graph. So you can have a start node 1 and end node 6, and that's completely okay. That's also completely same as from 6 to 1. So just make sure you write one of them, not both. So let's just start by completing this table real fast. First, you're going to take the one with the smallest possible weights. Now why take this table? Because that's exactly what the second rule of Kruskal's algorithm wants you to. So if you are going to take everyone in this table one by one, then you won't have to really watch out for this rule. Take the smallest possible weight you've got. That's 1 in this case, from 3 to 8. Do we have any more weights from 1 with the weight of 1? No, we do not. Now we go for a second one. Let's say we take this one. 2 from 4 to 7. Do we have any more with 2? Well, we do here. 2 from 6 2, 3. Then do we have any more with 2? No, we got 2 of this, and that's it. So we go on 3. Right, let's see, 5 to 2 with the weight of 3. Weight is, as said here, 3 from 5 to 2. The next one is going to be again 3 from 1 to 6. It's going to be a lot easier if you complete this table. You can do it without it, but it's going to be a lot easier, as said before. So let's go for next one. We've got 3 and 3 here, so the next one is 4. Let's say 4 from 9 to 5. So then another 4 right here from 5 to 8. Just make sure you don't skip any of these. Next one is 5 from 2 to 7. Do we have 6? Maybe, yes, from 1 to 9. So we've got 7 from 3 to 7. Now we do not have a cost of 8, but we've got a cost of 9 here. 9 from 8 to it. Next cost is 12 from 9 to 3. The last one is going to be 15 from 6 to 4. And okay, we've got this complete. Now we can start with this Kruskal's algorithm real fast and finish our graph. So once you've got this done, all you're gonna do is gonna take each one by one and check whether you form a cycle or not. Now only pay attention for the first rule, because the second rule automatically applies because you did this in ascending order. So just check for the first rule. How do you determine whether you put it in? So if we don't have a cycle, then include connection, else discard connection. I'm gonna color green if we can add it. The first connection, the smallest, we cannot form a cycle yet, so we're gonna add this one. The next one we've got is going to be, and I'll just color this green as well. The next one we've got is going to be 2, weight of 2 from 4 to 7, so weight of 2 from 4 to 7. Will this form a cycle? Well, it will not form a cycle, so we add it, and then again we're going to copy this part of our solution. Why I'm copying it bit by bit? Because that's exactly what the real algorithm will do. It will take a part of the solution each time and create it one by one. So that's the next one we are gonna put in our graph. You can see these are not yet connected. It's a separate entity at the moment. Now we're going for the next one, weight of 2 again from 6 to 3. Okay, if we add this part, this is still not going to form a cycle. So we're gonna do this like that. Then we're gonna color this green because we've added it, and then we're gonna color this green. And now I'm going to remove this part here because we do not need it. Okay, that's it, like that. Now once we've got this completed, we are going for the next one here with the weight of 3 from 5 to 2. So weight of 3 from 5 to 2, this is this lower one, and as you can see, you can add it without a problem because this is still not creating any connection. So let's just add it up like this. Then we've got to color this green because we've got this done. Then again, remove the parts that you do not need at the moment, right? So you do not have this connected yet, so remove this as well. Once we've got this done, this is how our graph looks. Go for the next one, weight of 3 from 1 to 6. This is upper one here, so I think we can add it without a problem because this would still not form a cycle. At each repetition, you just check, do we form a cycle or not? We can copy it because this will not give us a cycle. So like this. We've also got this one, remove this a bit. So this is the next one. Then we go weight of 4 from 9 to 5. From 9 to 5, this is going to be this one. Will this form a cycle? Well, it would not. So just add this. Then you just have to, again, you copy this part of the solution, right? So we are copying this part here. Then okay, this is another part. Then the next one, 4 from 5 to 8. So if you add this one, would this form a cycle? Well, it would not yet form a cycle, so you can just go ahead and add this one as well. So we've got it. So now let's just copy it like this. So we're gonna copy this part once again, like this. Okay, we're gonna copy this part like this, and then now you've got this added, right? So you mark this green. So you've got this part and this part. Now we're going for the weight of 5 from 2 to 7. Weight of 5 from 2 to 7. So if we add this, would we get a cycle? Well, no, you would not get a cycle. So you can just add this one as well. And we're gonna copy this part like this. Okay, now again we're gonna remove the ones that we do not need and color green. I mean, you don't have to. The next one is weight of 6 from 1 to 9. So from 1 to 9, weight of 6 is this one going to form a cycle. Now be very careful, because actually if you put this one here, I'm gonna mark it red so you'll see. If you put this connection with a cost of 6, you are going to form a cycle here, and you do not want that. From 1 you go through all these back to 1, or this side, it doesn't matter, but you will form a cycle, and this is what you do not want to do, because you would not get a minimum spanning tree that way. So we're gonna color this one red this time. So the next one is 7 from 3 to 7. From 3 to 7, if you put this here, then this would get you a cycle here. So you do not want this one as well. Go for the next one. Weight of 9 from 8 to 2. Weight of 9 is here from 8 to 2. If you put this one here, would this get you a cycle? Of course, you'd get a cycle here. So you do not want this one as well. Just make it like that. Next one is 12 from 9 to 3. So if we, again, just want to make things clear, if you put this in, would this form you a cycle? Well, of course it would. So you do not take this one. We do not take this one, so discard it, because we've got a cycle in all these. So, and the last one is 15 from 6 to 4, right? 15 from 6 to 4. Would this get you a cycle? Well, of course it would. This is here, and this would get you a cycle here, and you do not want that one as well. So you discard all these. You took all these. Now, if you want to get minimum spanning tree out of this, all you gotta do is just add up all the costs from these nodes. But before we do that, I want to show you the one last thing, is pay attention to this here. It says that our final graph must have 8 edges. 8 edges means it needs 8 connections. So we've got, let's just add up connections and see if this is right. So 1, 2, 3, 4, 5, 6, 7, 8. So now you know this is your minimum spanning tree, or minimal spanning tree, your final answer, and this is the way to go using a Kruskal's algorithm. Now let's just add up all this to get the final cost, and now your final answer is going to be 24, and that means that you have completed your problem.